This video is 1-6, solving compound and absolute value inequalities. So compound, if you think of even in your English classes, what does the word compound mean? Like a compound sentence, that kind of thing. Two or more, right? So compound inequalities is two inequalities joined by and or. And is an intersection of the solution sets, and or is a union of the solution sets. So on the back of your notes, I'm going to add some stuff that might be a little bit important to you. So let's go ahead and go to the back and write some things that will help us solve these inequalities later. So on the back, let's write and. An and graph is where it looks like this. You should remember this from Algebra 1. An and graph looks like it's in between. The shading is in between. So I don't care what the numbers are right now, or if it's open or closed, it doesn't matter to me. But and graphs should look like this, okay? Or graphs should look opposite, usually, okay? There's always an exception to the rule, right? Opposite usually. The way I remember that, or opposite, or opposite. They both have an O in it. So if that's the case, it would look something like this, where they're shaded in opposite directions. It also could look like this, where it's run over the other one, or overlap it, or whatever makes sense to you. So sometimes you'll get a graph that looks like this, where you have an answer like right here, but then when you do your second answer, it ends up running over the other one, so this is the only answer that's necessary. Then we're also going to write down absolute values. For absolute value, you want to make sure you get it alone first, just like before. Then, if it's less than or equal to, you use the word and. If it's greater than or equal to, you use the word or. The way I remember that, less than looks like an L, so this spells the word land. Greater than starts with a G, so it spells the word gore, like a gory movie. Obviously, that's not how you really spell it, but that's what helps me remember which one is which. So now let's go back to the actual questions and try to solve some of these. Solve each inequality and graph it. So with this, it's actually really easy. You're going to solve this one, find an answer. You're going to solve this one, find an answer. And it's just like section 1.5 where we're going to graph those, but instead of graphing one at a time, we're going to graph them on the same number line. So it's really easy. So what I'd like for you to try to do is solve this one, and then see what we get. So pause it and try it yourself first. So for this first one, what do you need to do to both sides? Minus 6 minus 6. So z is greater than negative 3. Super easy, right? You keep the word or. For this one, you're going to divide both sides by 2. So z is less than negative 6. So our answer right now is z is greater than negative 3 or z is less than negative 6. We'll go back and do interval notation later. For right now, I'm just going to try to keep it as simple as possible, and then I'll go back and possibly confuse you later, but you'll be okay. So again, just like before, I only write the numbers that we care about. We don't have to fill in every single number in between them. So in a number line, you know that it goes left to right, smaller to larger. So negative 6 should go on this side, and negative 3 should go over here. So let's just focus on this. Pretend it was like the section before it. Is this going to be open or closed? Open, right? Because this is just less than. Is it going to be shaded to the left or the right? Well, z is less than negative 6 would be everything to the left. The letter's on the left side, so you can just shade the way that the arrow is pointing. So right here. Now let's just focus on this part. Would it be open or closed? Open. Left or right? Right. So this is what an OR graph is supposed to look like. If you go back to what we put on the back, OR graphs should be opposite directions, and it was. So we probably did this problem correctly. Like I said, we'll go back and do interval notation later. So this question might look a little bit different to you. This is an and question. You can pull this apart and write the word and in between them. So I'm going to do that up here so you kind of know what I'm talking about. -7 less than or equal to 4d minus 3 is one of the parts of the question. And 4d minus 3 less than or equal to -1 is the second part. So you can keep it together if you want to, or you can pull them apart and solve them separately. Because this is an Algebra 1 concept, I'm not going to solve it this way on the video. If you want me to do that tomorrow in class, just let me know. I'd be happy to do that for you. But what I'm going to do instead is keep it all together and show you the newer, fancier way to do it. If you really want to, pause, solve it separately like this, get your answers, and come back to us at the end. Let me go ahead and delete this because that's a little confusing, I think, now. So at least try to watch this part and see if you understand it. It's not that tricky. So with this, we want d alone, right? There's a -3 in the way and a 4 in the way. Which one do we have to deal with first? The -3. We have to add 3 to make it go away. Well, what you do to one side of an inequality, you have to do the other side. Well, here we have two other sides, right? So I have to add 3 here and here. So what's -7 plus 3? -4, still less than or equal to 4d, this eliminated, less than or equal to whatever -1 plus 3 is. Well, that's a 2. So not that bad, right? Now what's in the way of d being alone? The 4. So I divide by 4 everywhere. So this ends up being -1 less than or equal to d less than or equal to, always reduce, 1/2. -1 less than or equal to d less than or equal to 1/2. If you pulled it apart and solved it this way, you would have gotten, let me just glance here, this would have been, this answer would have been -1 less than or equal to d, and this one would have been d less than or equal to 1/2, it looks like, with the word and in between them. But now that you're in Algebra 2, you need to start writing it properly. So it really needs to go smaller to larger, less. So you need to have -1 less than or equal to d and d less than or equal to 1/2 without the word and in there. So you just shove these two answers together where d was in the middle. Again, not that tricky, but maybe you need help in person, and that's completely fine. So let's go ahead and graph this. The numbers I need on my number line are -1 and +1/2. So -1 is obviously to the left of +1/2. Let's look at the 1/2 first. I feel like that might be easier for everybody. Is this going to be an open or a closed circle? It's going to be closed, right? Am I going to shade the left or the right side? We're going to shade the left side. So I'll do this real quick, but we're probably going to erase a little bit later, so maybe make sure you're using a pencil. Now let's do the d is greater than or equal to -1, or -1 is less than or equal to d. It depends on how you look at the question. Like I told you before, as long as the letter's on the left, you can shade whichever way the arrow is pointing. Here, the letter is not on the left, okay? So for me to do that, I would put d here and -1 here. The alligator was eating the d, so the alligator's still eating the d, right? So I would shade, it would be a closed circle on -1, and I would shade everything to the right, which is over here. So when you have an and graph, they want to know where they overlap. Well, here was our overlap, so the rest of that needs to be erased, in my opinion. The rest of that is not the answer, it's just what's in between them. Does this look the way an and graph is supposed to, where it's shaded in between the two circles or filled in circles? Yes, this looks like an and graph. So now that hopefully the Algebra 1 concepts are understood, let's go back and do interval notation, and then we'll finish the rest of the questions in just a second. Interval notation, if you remember, goes left to right, okay? So for this question here, if you cover this up, okay, pretend this isn't here, literally cover it up on your paper. Let's just look here. Would this be a negative infinity comma number, or would this be a number comma infinity question? This is negative infinity comma number. From left to right, it's negative infinity comma -6. Now, what does infinity or negative infinity get? Parentheses or brackets? Parentheses. What's the -6 get? It's an open circle, or it's just a less than symbol. Does it have a straight line? No, so it gets parentheses. Try the -3 answer. Z is greater than -3. You try that without me. Okay, for that one, is it going to be number comma infinity or negative infinity comma number? This one's going to be number comma infinity. So I need -3 comma infinity. What does infinity always get? Parentheses, and I accidentally already gave you the parentheses answer on the -3 because of the greater than symbol. When it's a or, you use the word union, so you use a U in between the two. This is your final Algebra 2 answer. This is the one that's going to get you full credit by the time you take the test. So this is interval notation. It goes left to right, and even still left to right. So you don't want the -3 answer to be in front of the -6 answer. That's technically not right. If that's really confusing, I get it. We'll do it in class, no big deal. So again, here, our answers lie in between -1 and 1/2. So you always go left to right. So this time my answer is going to be -1 comma 1/2. I don't have infinity in my answer because infinity isn't shaded anywhere. So my answer from left to right, would this be parentheses or bracket on -1? A bracket, parentheses or bracket on 1/2? A bracket. So your final answer for full credit would be -1 comma 1/2. Both of them would have a bracket. If you're confused, pause it, write down your questions, whatever you need to do, and we'll keep going. 20 and 21 are not that different from what we've done before. They're actually not that confusing either. So again, just like before, with an equal sign, you want to make sure your absolute values are alone, and then you set up your two equations. Well, here we're going to set up two inequalities, but the idea is the same. Is the absolute value alone? Yes, right? So we're going to set up -9n minus 3, and again, -9n minus 3. That does not change. The original question doesn't change, less than 6 for the first time you write it. For the second time you write it, it's the opposite, -6. If it was an equal sign, we just write an equal sign, right? But this is an inequality, so because I changed this to the opposite, I need to flip the sign. So it's now a greater than sign. So from here, you solve. You find n here, and you find n here. You need to go ahead and pause it, try it yourself, and see if you get it right. For this left one, you add 3 first. So we're going to get -9n is less than what? 9, right? Divide by -9 on both sides. So n, and that's a -1. We divided by a negative on both sides of the inequality, so we have to flip the sign. N is greater than -1. If you got that on your own, awesome. If not, look at this again. Same idea. Add 3. So -9n is greater than what? -3. Divide by -9, divide by -9, which flips your sign. -3 over -9, two negatives make a positive, and reduce it 1/3. So those are our two answers. However, we have to decide if it's and or or. If you go back to the notes that we put on the back with absolute values, after you get the absolute value alone, if it's one of these two symbols, it's and. If it's one of these two symbols, it's or. So we have to go back to this step here. Is this going to be an and or an or? That's an and, right? So technically, all the way down to our final answer, we should have the word and. The reason you choose here instead of this step is because we have both less than and greater than. Well, that doesn't make sense. So you choose it once you get the absolute values alone. If it's less than, it's and. If it's greater than, it's or. So let's try to write this the fancy way. This would be -1 less than n less than 1/3. If you're confused about that, come see me. So let's go ahead and put those on the number line. -1 would go here, 1/3 would go here. Would it be open or closed on -1? Open. And we would shade left or right? Right. Would it be open or closed on 1/3? Open. We would shade left or right? left. The reason I did this instead of shading is because I don't really like erasing things, and I know an and graph should be shaded in between anyway. So by drawing the arrows, I know that I would have shaded here, I would have shaded here, and the overlap shading would have been right here. So I didn't want to actually shade everything and erase it just because I find that annoying, but you're welcome to do that if you want to. Let's write that in interval notation. Is this going to be a number comma an infinity, or is this going to be a number comma a number? This doesn't have infinity shaded, right? So we're going to go from -1 to 1/3, always left to right. And what are both of these going to get? Brackets or parentheses? Parentheses. Very good. Why don't you pause it and try number 21? On number 21, again, the absolute values are alone already. If there was like a 2 here or something like that, they wouldn't be. You'd have to divide by 2 and then go ahead and do the next part, but that's not the case here, so you don't have to worry about it. So let's go ahead and set up our 2 inequalities. I'm going to go ahead and erase everything else just because, again, I feel like I'm running out of room. And I don't want to confuse you with all the extra writing. So if I need to go over to the left side, you'll know that it's really number 21 that we're still working on. So we would have -5j minus 4 and -5j minus 4. That does not change. For the first inequality, it stays the same, greater than or equal to 12, greater than or equal to 12. For the second inequality, the 12 changes to the opposite sign, therefore I have to flip my inequality. This is where we would decide and or. This is greater than or equal to. Is that and or is that or? It's or. So let's go ahead and write down the or so we don't forget that later. You solve both of these separately. You add 4, so -5j greater than or equal to, what's 12 plus 4? 16. You divide by -5. J is greater than or equal to -16 over 5. That doesn't reduce, so just leave it that way. You can change it to a mixed fraction if you want to, because graphing -16 over 5 might be confusing for some people. So that's the same as -3 and 1/5, if that's helpful. Over here, you add your 4. -5j is less than or equal to, what's -12 plus 4? -8. You're going to divide by negative, oops, we forgot something. I'm sorry, I'm thinking ahead too far. We divided by a negative. What did I forget to do? Flip my sign, right? So these should all be what sign? There we go. So these should now be less than or equal to. I was just testing you. All right, so here again, you divide by -5. That's why if you know that you're always going to forget to flip that sign if you don't write the dividing, then write that and go ahead and flip your sign as you go. 2 negatives make a positive, so that's 8/5, which again, if you want a mixed fraction, then that's the same as 1 3/5. It's all the same. With the word or in between or else it's not right. Whenever you have an or answer, you cannot write it the fancy way like we did with the and. You have to leave it j is less than or equal to 3 and 1/5 or j is greater than or equal to 1 3/5. There's no way to combine those together. You can't do that. So let's go ahead and put those on the graph. You can put -3 and 1/5 or -16/5. It really doesn't matter because we know the negative goes on the left and the positive goes on the right. So for this answer here, would it be open or closed? Closed, left or right? The letters on the left, the arrows pointing left, so you shade left. Open or closed? Closed. Left or right? Right. Is that the way an OR graph is supposed to look? Yes. So now let's try interval notation. I'm going to write -infinity comma number and then number comma infinity. So I'm going to put that answer over here. I want -infinity comma -16/5. What does -infinity get? Parentheses. What does -16/5 get? Brackets. Union because of or. And this time it's going to be 8/5 comma infinity. What does 8/5 get? Bracket. And what does infinity get? Parentheses. So that's your final answer along with the graph. Let's go ahead and try 23 and 26. We're going to write an absolute value inequality for each graph. So I have a little bit of, I guess, a trick to help you do it. Here's what I do. Absolute value of x minus the middle, and then you pick an inequality. It varies. I can't explain which one right now. We'll have to do a problem. And then it's the number, which stands for the distance from the middle. I know that doesn't make sense yet. Let's do one together. First, let's look at this graph. From -4 to 6, what is the middle number, or the midpoint? If you really want to do math, you could do that. Most of you can just count and see where that would be, right? So if you just counted, where is the middle here? It's at -1, isn't it? Or you could use your midpoint formula. -4 plus 6 over 2. Well, what's -4 plus 6? 2 over 2, which is 1. I think just now I said -1 because I was looking ahead, but obviously the middle is 1, excuse me. So 1 is the middle right here. Okay, so if you do x minus middle, that's what I was trying to say earlier, x minus 1, we'll pick our inequality, but not yet. And the number is the distance from the middle. How far away is 1? Or I guess I'll say it this way. How far is -4 away from 1? And how far is 6 away from 1? They're 5 away, right? So you see how far your end points are from the middle. What is the distance from the end point to the middle? So again, you could count or subtract or whatever makes sense to you. So for this part, we have to decide if it's less than, greater than, less than or equal to, greater than or equal to. So let's make it a little bit easier for ourselves, right? Is this open or closed? This is closed, so I know it's going to have that symbol. And now it's an in-between graph. So if it's an in-between graph with absolute values, what is that going to be? And or? That's an and. So it's in between, which means and, so it's less than or equal to. Absolute value of x minus 1 is less than or equal to 5. Let's try 26. I'll try to explain a little bit better. Let's go ahead and start with the middle. From -1 to 3, what would be my midpoint? 1, right? Right here is my midpoint. It's 2 away both directions. Again, you could use your midpoint formula if you'd like. So you could take -1 plus 3 and divide by 2, whatever works for you. So we have to do absolute value of x minus the middle. The middle we already said was 1. We're going to pick an inequality, and we said it was 2 spaces away. So to pick the inequality, first of all, is this and or or? This is an or graph because it goes in opposite directions. So it's either going to be this one or it's going to be this one. Greater than or equal to. Are these open or closed? Open. So we pick greater than. Absolute value of x minus 1 is greater than 2. All right, that's it for this section. If you have a ton of questions, no problem, just ask me.